Why is considering altitude crucial in psychrometric calculations? Imagine trying to design an air conditioning system for a mountain lodge or a high-altitude research station. You might think it's just about choosing the right equipment, but there's a lot more to it. When working with air properties, altitude plays a big role. It affects the pressure of the air around us, which in turn influences how air behaves in heating, cooling, and ventilation systems. Psychrometrics is all about understanding the thermodynamic properties of moist air. These include temperature, humidity, enthalpy, and density. These properties are essential for designing HVAC systems that keep indoor environments comfortable and energy efficient. But here's the catch. Most standard charts and calculations are based on sea level conditions, where atmospheric pressure is about 29.92 inches of mercury. As you go higher in elevation, the atmospheric pressure drops. For example, at around 6,000 feet above sea level, the pressure can decrease to about 24 inches of mercury. This change means the air becomes less dense, and the partial pressure of water vapor also shifts. If you ignore this and use standard sea level data, your calculations can be way off. You might end up overestimating or underestimating the amount of cooling or heating needed, which can lead to inefficient systems or uncomfortable indoor conditions. In HVAC calculations, the amount of heat transferred depends on air density. The common formula for sensible heat transfer includes a factor derived from air density and specific heat. When altitude causes air density to decrease, this factor no longer applies. If you don't adjust for it, your system's capacity might be misjudged, leading to incorrect sizing of equipment like fans, chillers, or heaters. This can cause higher energy costs or equipment failure over time. Many modern psychrometric software tools and charts now allow input of the project's altitude. This feature automatically adjusts the calculations for local atmospheric pressure, ensuring you get accurate data. With correct data, you can properly size systems, estimate energy loads, and maintain indoor air quality. This is especially important for applications like hospitals, laboratories, or data centers where precise climate control is essential. In short, considering altitude in psychrometric calculations is vital because it directly impacts air properties. Ignoring it can cause errors that ripple through the entire HVAC design process. By adjusting for elevation, you make sure your systems perform as intended, saving energy and ensuring comfort. It's a simple step that makes a big difference in creating efficient, reliable, and effective climate control solutions.